Welcome back, Algebra 2. We're going to be rationalizing fractions here. And they want you to practice doing this without a calculator. And I'm going to do the first couple just by doing probably what you're used to, where you're doing root 3 times root 3, which is root 9. And we know that the square root of 9 is 3. Let's see if you notice a pattern, because I can do the same thing with the next one. Root 7 times root 7 is root 49. And the square root of 49 is 7. And if I take it a step back, I hope it makes sense that root 3 times root 3 will just be 3, because this means the same thing as root 3 squared. This means the same thing as root 7 squared. And the square root and the square cancel each other out. So without doing all of that arithmetic then, I know that this answer should be 113. And then this next one is just saying that, okay, well, the answer will be whatever that's under the radical. Now we have this stipulation right here, this conditional, that a must be a positive number, which I hope makes perfect sense because we can only square root positive numbers. We've talked about that. So, it's kind of an old rule school, because as we get into calculus, you'll see we actually don't care that much about this. But anyway, we like to rationalize fractions where the denominator does not have the square root. So that's what we're going to practice here. And it's just a weird trick. I shouldn't even say it's a weird trick, because it makes perfect sense. Is we multiply the top and bottom by the square root of the denominator. Now, please remember, you cannot multiply a whole number by a radical. So just leave it as 2 root 3. And in the denominator, root 3 times root 3, you can think of that as root 9, or the shortcut we talked about earlier. Root 3 times root 3 is just regular 3. And we can use a calculator to talk about, the exact answer. So if you hit alpha x, you can make that fraction. 2 divided by root 3 gives you a decimal. So what I'm saying is that's not the answer I want. What I'm trying to show you is that 2 root 3 over 3, forgot to write my 3 down, is also equal to the same decimal. So we're doing this correctly, that 2 root over root 3 is the same thing as 2 root 3 over 3. So as I do the next one, I do want you to simplify a little bit further beyond that. So you multiply top and bottom by root 2, and we get 4 root 2 over 2. And then I do want you to simplify that, because 4 divided by 2 comes out to be 2 root 2. So that's good practice. In this next one, really the same work. Now you only need to multiply top and bottom by root 5. Now, maybe I should explain why this is acceptable. Is what I'm really doing is thinking about something divided by itself is equal to 1. And what I'm doing is I'm multiplying by 1. And if you multiply something by 1, you're not changing the value of it. So that's why this is acceptable. So anyway, I do need you to simplify this, because we have 5 root 5 over 3 times 5. Now some people actually figure out that that's 15, but I'm going to point out that you can cancel out those whole number 5s. So the best answer on this one would be root 5 over 3. Okay, I do want you to write it in simplest form. This is good math practice. Same thing with the next one. Now, instead of doing all of this work, I would actually simplify this to 2, because the square root of 4 is 2, over root 7, and then do my practice of rationalizing the denominator. You don't have to do it my way, but my way does give you the correct answer a lot faster. So as I look at the next one, as I mentioned, it might be to your benefit to rewrite that. Square root of the 1 is 1, square root of 2 I don't know yet. And then I can rationalize that by multiplying top and bottom by root 2. So what we get is root 2. Root 2 times root 2 is root 4. Or you can just say, the shortcut we've talked about, that the radicals cancel each other out, and we're left with this option 2. There's a lot of 2's on that problem. So why do we do that? Well, as we go into the next little bit, we can prepare ourselves for conjugate pairs. And let's remind ourselves about conjugate pairs is they're the same thing, except one is a plus and one is a minus. So it could be like a plus b and then a minus b. That's what we have on all of these. So a shortcut's about to happen. If you're not sure of the shortcut, go ahead and FOIL it out. So if you FOIL it, the first term will be 6 times 6 is 36. The outside, I hope you remember this rule, and the inside are going to cancel each other out because one is positive and one is negative. But we're not quite done with this problem because you have to do negative root 5 times positive root 5, which is negative 5. As a reminder, some of you might rewrite that as negative root 25, but that is the same thing. And then 36 minus 5 is 31. So what's the shortcut here is with conjugate pairs, the outside and inside cancel. You might even write that down. And when I say outer and inner, I'm talking about FOIL. So the shortcut on this one just being 2 times 2 is 4. 2 root 7 minus 2 root 7 cancels, but then you have a negative root 7 times root 7 is 7, and then 4 minus 7 is negative 3. So the next one, really the same thing, root 10 times root 10 is just regular 10. The outside would be negative root 20. The inside would be positive root 20. They cancel, and that root 2 times negative root 2 is 2, and 10 minus 2 is 8. So there's definitely a shortcut going on here, and if you're not familiar with the shortcut, my suggestion would be to go ahead and FOIL, and you'll still get the right answer, as long as your math is right. So in case you forgot those rules, here is your rule. Okay, kind of put a box around that or highlight it, because now we're ready to do the next one, is we want to make sure that we rationalize and reduce these fractions. So remember before, we cannot have a radical in the denominator, so our trick to this would be multiplying by its conjugate pair. So you have to think about what your conjugate pair would be. So why does this work? Well, you can distribute in the numerator, which is just itself. So we have 3 plus root 7. Anything times 1 is itself. And in the denominator, you get 9. The outside is positive 3 root 7. The inside is negative 3 root 7. They cancel. And root 7 times root 7 is just 7 with a negative in front. So how would I finish this answer? I would just leave it as 3 plus root 7 all over 2. So looking at the next one, what you got to do is multiply top and bottom by 3 minus root 3. Notice the changing the sign. Now what I usually do is mess with the denominator first. I just put an arrow, and because I like to mess with the denominator just to see what it equals first. And I get 9. 3 times 3 is 9. Negative 3 root 3 plus 3 root 3 cancel. And then root 3 times root 3 is regular 3. And so what I'm seeing is I get 6 in the denominator. And so what I'm thinking about is instead of distributing in the numerator, I can actually simplify 3 divided by 6. Or how should I rephrase it? That 3 goes into 6 2 times. And that's what I mean by simplify, is we can just leave our answer like that. Okay, and you can simplify when you're multiplying. So let's work on the next one, really the same arithmetic. Notice I'm changing the operation in the denominator to be the opposite. So when I work in the denominator, I get 16. Root 6 times root 6 is just 6. Okay, that's 10. And I'm thinking about how 2 goes into 10 5 times. So the best answer that we can come up with is 4 root 6 all over 5. And if this isn't making sense, I would still encourage you to write down questions, pause the video, come back, and try to see if they make sense. So as I mentioned, it's important that you are doing the conjugate of the denominator. So that's why I'm doing 3 minus root 5. Easy to mess this up. 3 minus root 5 on top as well. So this time, what you have to do is make sure that you FOIL both top and bottom. Now on top, you end up with 3 times 3 is 9. You have a negative 3 root 5 with another negative 3 root 5. That's negative 6 root 5. and root 5 times negative root 5 is a positive 5. And in the denominator, you still are foiling, but remember, the outside and inside terms will cancel, and our goal is to get rid of the radical, which we do. It's just 9 minus 5. So in the numerator, we have this 14 minus 6 root 5. Notice I'm combining like terms. The constants are like terms. All over 4. Now, we do want you to reduce this fraction because all 3 of the whole numbers are divisible by 2. So what I can do is rewrite this as 6 minus 3. 14 divided by 2 is 7. 6 divided by 2 is 3. Do not change the radical all over the denominator. If you're not quite sure that that is correct, we can use our calculator to double check. I already forgot what it was. 3 minus root 5. Let me make this bigger. There we go. Alpha x. 3 minus root 5 over 3 plus root 5. Alright, and then I said the answer was going to be 7, I already forgot what it was, minus 3 root 5 all over 2. Look at that. I did it perfectly. And we know because we got the same decimal. So same work on the next one. Let me change colors just to change colors. Do the conjugate of the denominator. And whatever you do to the bottom, you have to do to the top. So in the denominator, 6 times 6 is 36. The outside and inside terms cancel. Minus 6, because the radicals cancel out. In the numerator, we get 18 plus outside is 3 root 6. Inside is 6 root 6. And then root 6 times root 6 is just regular 6. So as I simplify that numerator, I'm getting 24 plus 9 root 6 all over 30. And all 3 of those numbers, all 3 of those whole numbers, not the radical. I know the radical is also divisible by 3, but all 3 of those whole numbers are divisible by 3. So my best answer would be 8. 24 divided by 3, 9 divided by 3 is 3. And then 30 divided by 3 is 10. That's the simplified answer, the best answer on that. And the very last exercise is practicing the same thing. You might want to hit pause in the video, see if you can come up with the right answer. Otherwise, you can follow what I'm going to do. Top by the same thing. So as you work through it, if you just work with the denominator, you can see you're going to get 8 minus 2, which is 6. Notice that that's not any of my options. So you definitely need to still do the numerator where you're foiling. Outside is negative 10 root 2. Inside is negative 4 root 2. So that's 14 root 2. And root 2 times root 2. Negative times a negative is positive. So we have 42. Minus 14 root 2. And the best thing I can say is each one of those is divisible by, oh yikes. I definitely found my mistake. I don't know if any of you caught it. It was 4 times 4 is 16. Silly me. 16 minus 2 is 14. There we go. And now each one of those numbers is divisible by 14. 42 divided by 14 is 3. 14 divided by 14 is 1. And then 14 divided by 14 is 1. But you don't have to write divided by 1. As you look at the options, the correct answer is option 1. There you go. So sorry I started off with a mistake. That was an easy one to catch, though. So that was kind of obvious that when you FOIL, the first term is 4 times 4. Anyway, now we are good and ready for the homework.